Hello and welcome to all students. This is FY BCom semester 2nd class Mathematical and Statistical Techniques 2nd unit number 2 derivatives and applications. Today we will see the derivative of a function and applications of the derivative. So first of all we see the derivative as a rate of change. Derivative as a rate of change. So first of all we write derivative as a rate of change. Derivative as a rate of change. Okay. We learned function in detail in the last chapter. A function in general is denoted by the notation y is equal to f of x. We know this thing where x is called as independent variable and y is called as dependent variable. We observe that unless a function is a constant function, the value of the variable y changes with the change in the values of x. Means if we change the value of x, so as it is dependent variable, dependent, and this is independent variable. So y depends on the value of x. Okay. So whenever the value of x changes, the value of y also changes. Okay. We observe that unless a function is constant, the values of the variable y equal to f of x changes with the change in the values of x. In this chapter, we will find out the rate of change of y equal to f of x with respect to the change in x. This rate of change is called as derivative. Okay, this rate of change. So rate of change. The rate of change. So just write here the rate of change in the values of values of y, the rate of change in the values of y with respect to the change in values of x, change in values of x, okay, is called as derivative of y with respect to x is called as derivative of y with respect to x. Okay, and it is denoted by this notation dy by dx. Okay, so this is the notation. Okay, now let us take some examples. For example, if the demand function is denoted by d is equal to f of p, function of price, f of p, then derivative of d with respect to p is denoted by the notation dd by dp, or we have another notation d dash, or here we can have one more notation y dash also. Okay, so d dash is the derivative of d with respect to p. Okay, similarly we have second example. This is our example 1. example 1. Now we write example second. Suppose c cost function is given by c equal to f of x and it depends on x. X is the quantity. Then derivative of cost function c with respect to x is denoted by this notation, and we have another notation c dash. Okay, note that the derivative of every function need not exist. That is important. Derivative of every function need not exist. Derivative of every function need not exist. Okay, that is important. There are some functions which are having no derivative. The function y is equal to f of x is differentiable if it has derivative. Okay, so now next very important is derivative of some standard function. Derivative of some standard functions. So there are some standard functions and we write the derivatives of these functions, and if we know the derivative of these standard functions, then we will be able to solve examples on derivative. So let us take first standard function, and that first standard function is, see here, if y is equal to k, where k is constant, then derivative of this constant function dy by dx is equal to 0. So this is one standard function, constant function, and its derivative is always equal to 0. That is one result or one standard derivative. Now second, if our function is like this, if y is equal to x raised to the power n, where n is some fixed real number, n real number is some fixed real number, then derivative of y with respect to x is equal to n times x raised to the power n minus 1. Okay, this is our second standard function and its derivative. Our standard function is y equal to x raised to n, and its derivative is dy by dx is equal to n into x raised to the power n minus 1. Now let us go to the next third standard function. Okay, third standard function is right here. If y is equal to e raised to the power x, okay, then exponential function, then its derivative dy by dx is equal to e raised to the power x. Okay, standard function e raised to the power x and its derivative is dy by dx is equal to e raised to the power x. Okay, now next fourth standard function is, if we have y is equal to a raised to the power x, where a is a fixed positive real number. What is a? A denote real number. Then we write the derivative of this function. The derivative is dy by dx is equal to a raised to the power x into log of a. Okay, and last standard function is, fifth function is y is equal to log x. It is called as a logarithmic function, where x takes values greater than 0, then we write the formula for derivative of this standard function with respect to x is dy by dx is equal to 1 upon x. So all these are the standard functions and based on and their derivatives, and based on these standard functions we try to solve some examples now. Okay, so examples. So let us take first example, question number 1. Okay, first example, if y is equal to 10, obviously here 10 is a constant number, constant. Example, find derivatives. Our question is find derivatives for this function. So its derivative dy by dx is equal to, it is equal to 0 because function is constant, and as we have seen above, the derivative of constant function is always equal to 0. Therefore derivative of function y equal to 10 is 0. Okay, now let us go to the second example, example number 2. So function is y equal to x. Okay, so y equal to x, so this function is of this type, y is equal to x raised to the power n. What is n here? N is equal to 1. Okay, so therefore the derivative of this function dy by dx is equal to, and its derivative, how to write derivative of this function? We know that it is 1 into x raised to the power 1 minus 1, and it is equal to 1 into x raised to the power 0, and it is equal to 1. So dy by dx is equal to 1. So our function is y equal to x and its derivative is 1. Okay, so now today we will stop here. Okay, remaining examples we will see in the next lecture. So let us go to end this lecture, and thank you. So remaining examples we will see in the next lecture. Thank you.